All right, so to recap, the question asked, find each value requested for the distribution of scores in the following table. And what I've done is I've transferred that table to my work so that I can see that. One critical thing to remember with these questions is that these are the scores, and these are how many times each of those scores happens. And so with a distribution like this, it doesn't work with a grouped frequency distribution, but with a distribution like this, we can reverse code and see what the data set was. So we had 1 6, 2 5s, 2 4s, 4 3s, 3 2s, and 2 1s. So be careful. This is how many times it occurs. These are the scores. But this is what you need to keep in mind. And you don't want to have to go backwards to this and then to calculate your values. You want to learn how to do it from the frequency distribution table. Because in this case, we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 scores. But if, for example, you have a frequency distribution that has 30, 40 scores, it's going to be very time consuming and error prone to go from there to here and then from here to calculate out. It's much better to figure out how to do it from the distribution table. And that's what I'm going to show you. So the first thing to calculate is n, and n is the number of scores. To calculate n, we're going to take the sum of the frequencies. We're going to count up or add up these values. 1 plus 2 plus 2 plus 4 plus 3 plus 2. And 1 plus 2 plus 2 plus 4 plus 3 plus 2. We get 14, which is the number that I had told you before, right? I had counted out these values, forgetting that I was about to calculate it. Counted out these values and I had 14. B is the sum of x. So this is adding up all of the x scores, all right? And one mistake that I see is that students just add up the x column. Well, that's great, that's a start, but you have to remember that there's 2 5s, and there's 2 4s, and there's 4 3s, and so on. And so you could add up all of these numbers, but alternatively, you could calculate the sum of x times the frequencies. And if you do that, then you have 6 times 1 plus 5 times 2, which allows you, what it's doing is it's counting 5 twice. 4 times 2 plus 3 times 4 plus 2 times 3 plus 1 times 2. So 6 plus 10 plus 8 plus 12 plus 6 plus 2. So now if I do that, 6 plus 10 plus 8 plus 12 plus 6 plus 2, I get 44. In terms of showing your work, at least in my class, you need to show me your answer, but also at least one of these 2 lines, if not both. You need to show me your work. Sorry about that. Been talking too much recently and I'm getting a bit of laryngitis. The sum of x squared, again, here you need to be careful with your order of operations. because exponents happens before summation. So what we need to do is we need to take the x value, square it, and then multiply it by the frequency. So then we get 5 squared times 2, 4 squared times 2, 3 squared times 4, 2 squared times 3, 1 squared times 2. 6 squared is 36. 5 squared is 25. Then we'll multiply it by 2. I'm breaking it out a bit more. 4 squared is 16. Multiplied by 2. 3 squared is 9. 2 squared is 4. 1 squared is 1. So 36 plus 50 plus 32 plus 36 plus 12 plus 2. So we do that 36 plus 50 plus 32 plus 36 plus 12 plus 2. I get 168. It's really important for you to show your work. What you didn't see off to the side is that as I was typing, I nearly did a subtraction instead of an addition. If I hadn't caught that as I was working along, I would have had the wrong answer. When I grade the exams, I give part marks. And so if you have all of this work shown and you're right up to this point, but you get the wrong answer, you're still going to do really well on the exam because you've shown me your work. Okay? And that is the end of question 4. But I want to show you sort of an extra piece. Where we have the sum of x in brackets and then the squared. This is where you would take the sum of x that we calculated up here and you can just plug it down here and you get 44 squared, which is 1,936, which is a dramatically different answer than what you get if you square it and then add it up, right? So the order of operations is really, really quite important.